Alright kids, this one is a short video about how to do ionic compounds. This is naming binary ionic compounds, which is just what you see right there on the screen. Then we're also going to talk about naming polyatomic ion compounds, so it's called ternary compounds. And finally, we're going to talk about doing multivariable compounds, which is the last part, and that's the transition metals. Okay, so first things first. With ionic compounds, what you have to do is name them this way. It's going to be the symbol, so it's barium in this case, and then chloride. Now the reason why it's chloride and not chlorine is because whenever it's bonded, it takes on a different form. Okay, so this next one, NaCl, is going to be sodium chloride. Okay. Now K3P is going to be potassium phosphide. Alright, and then the last one is magnesium oxide. That's pretty self-explanatory. So that's not too bad. So at this point in class, I would have had the students look over homework 3 and questions 25 through 28. Okay, now for this one, CD, Zn, and Ag. CD is 2+, Zn is 2+, and Ag is plus. That means that we know their charge. For sure, no problem, 100%. We know that's what their charge is going to be. That's going to come into play later. Alright, so aluminum oxide. What we got going on here, for aluminum, it's going to be Al. Apologize about that. My computer's running a little slow today. Al, and then oxygen is going to be O2-, okay? So the Al is going to be 3+, and the oxygen is 2-. Now, we get these numbers from looking at the periodic table, and we talked about the oxidation numbers. So that's what they are. Al is 3+, O is 2-. The 3 comes down here, and the 2 comes over here. We drop the charges, and we just leave it as Al2, O3. That's it. Done. Moving on to the next one. Mg, magnesium chloride. So Mg, and then it's Cl. And Mg has a +2 charge, and Cl has a -1 charge. Draw it, crisscross it, and it becomes MgCl2. Alright, now calcium oxide. This one's a little bit tougher because of this reason. Calcium is Ca, and oxygen is O. That's 2-, and that's 2+. Whenever you crisscross the charges, that becomes Ca2O2. But just like in math class, if you had an equation, or sorry, a fraction that said 2/4, you reduce that to 1/2. We do the same thing. So it's CaO, and that's it. That's the same thing as MgO that was on the other slide. Now with lead sulfate, that's Pb4+, and then S2-. So that's Pb2S4. So then it becomes PbS2, because those two reduce. So at this point in class, they would have done those numbers on homework 4, or homework 3, excuse me. Alright, now here's your polyatomic ions. Pause this and copy these down, because you're going to need them for later. And now what this says, the way you read this off, is SO3 2-. So what that means, is you have an S, an O, a 3, and then the charge is going to be a 2-. This acts as one compound, okay? So the SO3 is one huge charge. Alright, now we look at back. Potassium phosphate. Potassium is a K with a plus on it. Phosphate is PO4 3-. Now what happens is you always put parentheses around your polyatomic ions, and you drag the charges over to the other side. So this becomes K3 PO4, and now I drop the parentheses because this is a +1. I don't need to put it there because it's already known, it's assumed. Okay. Now the next one we have is magnesium hydroxide, and that's OH. That's OH- and Mg2+. Okay. So in this case, we keep our charges. So then it's going to be Mg OH2. Sorry, we keep the parentheses, that's what I'm going to say. Now, the reason why is if we go back and we look at the Lewis-Dot structures. The Lewis-Dot structure for Mg is dot, dot. Now, hydroxide is O, and it has 6 and then hydrogen, which has 1. So what happens is that it still has one lone pair, or one lone electron. So it has an overall -1 charge, which is what it is. It's a -1 charge. So what that means is that this one electron will bond with that one magnesium. So that OH goes up there. Well, we need another one, because magnesium still has one extra one. So what we're going to do is we're going to have 2 hydroxides. So that's where this comes from. Now, whenever they bond, what ends up happening is we can go ahead and erase that minus charge, because, well, I can't erase it, but that's fine. So, because it's now bonded. So that's the reason why we need 2 H's and 2 O's, not 2 H's and 1 O. Alright, aluminum nitrate, that's Al, and that's 3+, and nitrate is NO3-. So we put our parentheses around that. 3 comes down over here, -1 comes down over here. So then that becomes Al3, sorry, just Al, and then NO3, 3. Because again, we need 9 oxygens and 3 nitrogens this time, because of the way that NO3 is arranged. Then we got calcium sulfate, which is Ca2+, SO4, 2-, crisscross, and it's CaSO4, because those 2's cancel out. Alright? Coming up next. That was another drawing of what I had. Okay. This is where we do 3, 7, 9, 13. That's actually where we stopped at on the first day that we did this. So let's keep on going. We got CaOH2. So what you do with these guys is you write down what they are. So that's calcium. And then the OH is going to be hydroxide. And that's it. Just write calcium hydroxide. That's all you got. Sr3PO42. So that's strontium phosphate. That's it. Nothing else. So hopefully you got that this one is sodium acetate, that one's calcium carbonate, and that one's calcium sulfate. Okay? So there you go. Alright, last one. So here is the variable charged ions. So like I said, for CD, Zn, and Ag, we know what the charges are. Everything else, not too sure. So for iron, it's going to be Fe, and its charge right here in Roman numerals is going to be 3+. Chlorine is -, so now we crisscross, and it's going to be FeCl3. So then we come back down. This one is going to be FeCl2. And then this guy right here, see if you can figure it out. Yep, it's Cr3P4, because this right here is the Roman numeral for 4. Okay? If you have questions with that, give me an email or let me know in class. Okay? Hope you enjoyed it.